Okay, before we begin today's lesson, I want to remind you of something. Do you remember in our foundational lessons when we talked about the carpenter and their toolbox? We say that every tool has a specific job and that none of them are extra or redundant. Now, I want to draw your attention to a very important detail. Observe these tools. Sometimes two tools in a toolbox can look very similar in shape, but their jobs are completely different. This is the exact same situation in Python. Today, we are going to learn about a new tool that, on the surface, looks almost 90% identical to a list, but it was created for a completely different and specific purpose. Let's find out why Python needs this similar looking tool. Okay, now that we have completely mastered the list, it's time to introduce our second data structure, the tuple. The best part about learning tuples is that you already know about 90% of it because it is incredibly similar to a list. First, let's talk about the similarities between a tuple and a list. They are ordered. Just like a list, the items in a tuple have a specific defined order, and that order doesn't change. They can be accessed by index. In the exact same way, you can use between two square brackets 0 index to get the first item, and -1 between two square brackets for the last item, and slicing like between two square brackets 1:3 to get a range of items. They can hold different data types. You can mix integers, strings, and booleans together inside a single tuple. So, if they share all of these features, what is the difference? And why do we even need tuples? This brings us to the one single but critically important difference. Let's go back to our library analogy. Do you remember how we said a list is like a bundle of books tied together with a simple rope that you can untie? Now I want you to imagine a tuple as the exact same bundle of books tied with the same rope, but this time there is a strong permanent padlock on the knot. What does this padlock mean? You can still see all the books in the bundle. You can see which book is at which position. This means you can read the data, but you absolutely cannot break the lock to open the knot. You cannot add a new book to the bundle. You cannot remove a book from the bundle. You cannot change the order of the books. The bundle is locked and cannot be changed. This property in programming is called immutable. So this is the core difference. List is mutable, can be changed like an untied bundle. Tuple is immutable, cannot be changed like a padlock bundle. Welcome to the practical session for tuples. In our theory section, we described a tuple as a padlock bundle of books, a collection of items that is immutable, meaning it cannot be changed. Let's create our first tuple. The standard way to create a tuple is by using parentheses. I will create a new file, name it mytuple.py. The standard way to create a tuple, my underscore books equal to open and close parentheses, mathematics, comma, art, comma, chemistry, comma, English. Let's check its type. Print. The type is type function my underscore books. And let's access an item just like a list. Print the book at index 2 is my underscore books index number 2. Let's see the result. As you can see, it works just like a list for reading data. But now for the most important test, what happens if we try to change an item, just like we did with our list? Let's try to replace chemistry with physics. My underscore books, position number 2 equal to physics. Let's see the result. And there it is, a type error. Python is telling us tuple object does not support item assignment. This is the PVM, our librarian, telling us you cannot change this bundle. It is locked. What if you try to add a new book? My underscore books dot append function history. Let's check the result. Another error, an attribute error. Python says tuple object has no attribute append. The tools we use it to modify lists like .append function or .remove function simply do not exist for tuples. This proves that tuples are truly immutable. Now let's look at a special feature of Python that can sometimes be confusing. Look at this line of code. What is this? Look at my underscore data equal to 10, comma, 20, comma, string Hama, comma, true, without parentheses. Note, we didn't use any parentheses. So what did we just create? Let's ask the PVM. Print the value is, comma, my underscore data. Print the type is, comma, type my underscore data. Let's check the result. It's a tuple. This is a feature called tuple packing. When you write a sequence of values separated by comma, Python by default packs them together into a tuple. Why does this happen? It's because tuples are a fundamental and efficient way for Python to group data together. So while it's always good practice to use parentheses to make your code clear, you should know that the commas are what truly create the tuple. To understand this, let's go back to our library analogy. Imagine you carry a stack of books to the librarian without tying them together with a rope. You tell the librarian, this is a new package. The librarian, or we can say the PVM, is smart. They see that you have brought a collection of items together, so they assume you intend for them to be treated as a single bundle. They automatically handle them as if they were a locked bundle, a tuple. This brings us to the final and most tricky secret of tuples. What if you want to create a tuple that has only one item inside it? Let's try this. Attempt 1. Single underscore item underscore tuple equal to 10 between parentheses. Attempt 2. Correct underscore single item underscore tuple equal to number 10 followed by comma between parentheses. Look closely. The only difference is that teeny comma at the end of the second one. Let's ask the PVM what it thinks these are. Print the type of a single underscore item underscore tuple is type single underscore item underscore tuple, and print the type of correct underscore single underscore item underscore tuple is type correct single item tuple. This is fascinating. When Python sees number 10 between two parentheses without comma, it thinks the parentheses are just for mathematical grouping, like in 5 plus 5 between parentheses. So it says this is just a simple integer. But when Python sees number 10 between parentheses followed by comma, that comma, which we call it a trailing comma, is a signal to the PVM. It's as telling it, hey, this isn't for math. I'm intentionally creating a bundle, a tuple, that just happens to have one item in it. So the rule is, if you ever need to create a tuple with a single item, you must Include that trailing comma. It's one of the unique quirks of the language, and now you understand exactly why it exists. Python gives you a very elegant way to assign the items inside a tuple directly to multiple variables. This is called tuple unpacking. For example, my books equal to mathematics, art, and chemistry. Book 1, comma, book 2, comma, book 3 equal to my books. Print book 1, print book 2. Let's see the result. Imagine you have your padlocked bundle. Instead of taking out each book one by one, you can, in one single action, place all the books onto a table that has specific spots ready for them. Okay, before we conclude this lesson, there is one final critical note. This is one of those details that separates professional programmers from beginners. The question is, when we say a tuple is immutable, does that mean that nothing related to it can ever be changed under any circumstances? The answer is a bit more subtle. Let us go back to our padlock bundle analogy one last time. Imagine that inside our padlocked bundle, next to the regular books, there is also a bundle that can be untied. This unpadlocked bundle represents a list that is inside our tuple. Now, what are the rules of the padlock, the tuple? You cannot take the unpadlocked bundle out of the tuple because the tuple is immutable. You cannot add a new book next to the unpadlocked bundle because the tuple is immutable. What does this mean? It means that if a tuple contains a mutable object like a list, the tuple itself cannot be changed, but you can change the contents of that mutable object inside it. Let us see this in practice. My underscore tuple equal to open and close parentheses 1, comma 2, comma list 3, comma 4, comma 5. A tuple containing a mutable item, a list. Can we change the first item of the tuple? No. This will cause a type error. But can we change the list inside the tuple? Yes. Let us change the first item of the list, which is at index 2 of the tuple. My underscore tuple, index number 2, and inside the list, index 0 equal to 99. Print my underscore tuple. Let's see the result. Look at that. The tuple itself didn't change. It still holds the same 3 items. But the contents of the list inside it did change. The academic summary. The tuple stores the memory references to the objects it contains. The reference to the list cannot be changed, but the list object itself at the other end of that reference is still mutable. Understanding this subtle destination is a mark of a truly deep understanding of how Python works.